Greetings. We're going to do start chapter 7. We're starting, first lesson for chapter 7 is considered an introduction. We need to go through all of our laws of exponents as we will be heading towards working with logarithms, which you'll come to understand that the answer to a logarithm is an exponent. So that's why we need to uh, go back over all of our rules of laws of exponents here today. So if you haven't already taken out your notes, please do so, and we're going to get started. There will be a few definitions, a couple of examples, and then the book assignment actually will have a worksheet that will go with it, and it'll tell you uh, what problems to do. Some of them will come from chapter 5, actually. First thing, we have to remember that when we take a base, if I'm saying 2 to the third, that means that it's that's the base, that's the number that's being raised to the exponent or the power 2 to the third, and we could calculate 2 to the third and it would be equal to 8. Write each expression using exponents. 4 is being multiplied together 1, 2, 3, 4, 5 times. So I have 4 to the fifth. Repeated multiplication, that's our exponent. Base is 4, exponent is 5. Next one, I have m 3 times k 3 times m cubed times k cubed. And then I have on the top of my fractions here, I have x 3 times, w 2 times, and on the bottom I have y 3 times and z 2 times. This is all review for you. Hopefully nothing mind-blowing. Remember, anything to the power of 1 is equal to itself. X to the first power is equal to x. A good example of this is if you're 16 years old, you don't run around saying that you are 16 to the first power years old. That would sound odd and people would look at you strange. 1 to any power, if you're going to multiply 1 repeated number of times, 1, if it's 1 to the 7th, it's still 1. And then this is one that we do need to remember. Anything to the power of 0 is equal to the number of 1, and that's one that people can get confused by sometimes. So please remember that anything to the power of 0 is equal to 1. Okay, what is the power control? I've done this one a few times for a lot of different classes, the negative 2 to the fourth or negative 2 to the fourth. This one up here, if you type this into a graphing calculator, depending on the type of calculator that you have, this tells me to do 2 to the fourth, which is 16, and then make the answer negative. The answer to this problem is negative 16 because it says this is exponents and this is multiplied by a negative. And if you remember back to order of operations, you need to do the parentheses first, and then you do your exponents, and then you do your multiplication and division, and then addition and subtraction. So down here, this tells me to do the number negative 2 4 times. So that's negative 2 multiplied together 4 times. So if you put negative 2 in parentheses 4 times, this is positive 16. So you need to be careful with that. So this one looks like negative, and then there are 1, 2, 3, 4 of them, which gives me my 16, make it negative. This one is negative 2, and we're doing it 4 times, and if we multiply a negative 4 times, we get a positive. So there's the difference between those two. This one tells me 5 squared. 5 squared is 25. 25 times 3. So this is 3 times 25, which is 75. This is the same thing. This tells me take the number 5 and square it, and then multiply it by 3. So really, you really need to watch out with negatives. Those are always going to cause more of a problem. So this is also 3 times 25, which is 75. A couple of definitions here. A monomial, and if you don't get these written down, they're also you can also find them in your book. A monomial, mono means one, is a number variable or the product of a number and one or more variables with non-negative integer exponents. A binomial would be the addition or subtraction of two things. Trinomial we have 3 things, and so on and so forth. So monomial is going to be 1. A constant is a monomial that is a real number, like the number 3 here. If you think about a variable varies because it can take on anything that we tell it to be equal to, but a constant is always going to remain the same, thus the name constant. This one up here we would have to deal with v to the third, 234 to the third, and then we would multiply by w, but more on that after a little bit. So constant does not have an x, y, v, w, anything added to it, or a, b. Monomial, one term, mono, one. Okay, we got a bunch of rules for exponents to make your life easier. If you're going to multiply things together with the same base, then you're going to add their exponents. And let's take this one off to a separate page here a little bit, and then we'll come back to this. So it's 5 cubed times 5 squared. So if I have 5 cubed times 5 squared, what does it mean to be 5 cubed? It means 5 times 5 times 5. What does it mean to be 5 squared? It means 5 times 5. So really this is 1, 2, 3, 4, 5. It's 5 multiplied together 5 times. So if we go back over here, it says to multiply two powers that have the same base, we add their exponents, because this is 3 5s times 2 more 5s. So it's repeated multiplication times repeated multiplication. So when I look at this one up here, I see 2a's multiplied, and we can multiply in any order. So I could rewrite this as a squared, a cubed, a, b cubed, b cubed, and I have 2, 3, 4, 5, 6. There are 6 a's in here being multiplied together. So that would be a to the 6th, and I have 3 b's times 3 more b's. So I have b to the 6th. So because of repeated multiplication, when we multiply things with the same base, we add their exponents. Same thing here. I have 3 2's multiplied together with 4 2's. Now, instead of actually writing them all out like this, that's cumbersome, we can use this rule that we have written down over here. A to the p times a to the m. Multiplying things with the same base, the bases have to be equal. In this case, they're a's. We add the exponents. So I have 2 to the third times 2 to the fourth. That's 7 2's being multiplied together. 2 3's times 1 more 3. 3 times 3 times 3. That would be 3 cubed. And then we could take it from there. Even though we have parentheses here and parentheses here, this is one big long multiplication. We can multiply in any order. So I have 1 2 and 4 more 2's. 5 total 2's being multiplied together. 3 4's and 1 more 4. I have 4 to the 4th power. So when multiplying things with the same base, we add their exponents. The next one is when we're raising a power to a power. I'm going to take this one to a separate sheet, and we'll see what happens. That was x squared to the 5th power. Now anything to the 5th power means multiply it together 5 times. 1, 2, 3, 4, 5. Whoa. 5. X squared 5 times. Anything squared, we just got a rule for this. 2 of them, 4 of them, 6 of them, 8 of them, 10 of them, which means that I can turn this into x to the 10th. And what is the relationship between 2 and 5 and 10? 2 times 5 is 10. So I could turn this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what x squared. These 2, and then these 2, and then these 2, and then these 2, and these 2. But that's ridiculous. This would take us forever. And we even turning this into x squared 5 times. 1, 2, 3, 4, 5. Well, that's really repeated addition. Well, what's repeated addition? Hey, multiplication. So I can do 2 times 5. So this rule says to find the power of a power, when we're raising a power to a power, we multiply the exponents. So when we're multiplying things with the same base, back here we add the exponents. Raising a power to a power, we multiply. So 3 to the 5th to the 3rd. 5 times 3, 3 to the 15th. Okay? So if I had x to the 4th to the 9th. Now you wouldn't want to write out 9x to the 4th and then figure it out. So it's x to the 4th 9 times is really what it is. X to the 36. So multiplying things with the same base, or excuse me, raising a power to a power, multiply the exponents. Next one, to find the power of a product, multiplication. Find the power of each factor, and then we can multiply them out. So basically, when we have more than one thing in parentheses raised to the same power, we can raise everything to that power. And if we take this one to a separate page, x times y cubed all squared, x times y cubed all squared, what does it mean to be squared? It means this one once, and it means this one a second time. Well, we just learned x times x, x squared, y cubed times y cubed, multiplying things with the same base, 3 of them and 3 more of them, 6 of them. Okay, wouldn't it have been easier just to say make it x squared and make it y cubed squared, raising a power to a power, and I get the same thing. Again, when we want shortcuts, I know everybody loves a shortcut. More than one thing in parentheses raised to the same power, raise all of them to that power. So I can go over here and say this will be 2 squared, 4, and times 5 squared, 25, and I get 100. Now, based on what you already know about order of operations, I can do 10 squared 100. Hey, more than one way to do a math problem, right? Next one, 3 squared squared, 3 to the 4th, 4 cubed squared, 4 to the 6th. Again, I have 4 cubed 2 times. That was going to be 6 4s being multiplied together. And on the bottom, x to the 5th 3 times, x to the 15th, y cubed 3 times, y to the 9th. Raising more than one thing to the same power, raise everything to that power. Okay, a couple of practice. Based on order of operations, I would start inside these big brackets, and I would take 2 cubed squared. So this is going to be a power to a power to a power, which means aren't we going to do 2 cubed 2 times, which will be 2 to the 6th, and we're doing all of that 4 times, which is 2 to the 24th. Couldn't I do 3 times 2 times 4, which is 24, right out of the chute and get 2 to the 24th? Absolutely. Absolutely. This guy over here, order of operations, these are in parentheses. These are being raised to the power. I need to raise these to the power first. So I'm going to have 3pt cubed. P cubed squared. Raising a power to a power, we multiply 6 times. P cubed and P cubed. That will be 6 total. T to the 4th squared. T to the 8th. Now I can go and multiply in any order. So I have a 3. I have 1p and 6 more p's. Multiplying things with the same base, add the exponents. Multiplying things with the same base, add the exponents. T to the 11th. There we go. You can do this one a wide variety of ways. Let's simplify what's inside these brackets first, and then we'll raise everything to the 3rd power. Or I can do a cubed, b cubed times b to the 4th, c to the 4th, and then I could make that into a cubed, b to the 7th, c to the 4th, and I could then raise everything to the 3rd. 3 times 3 is Niner. Did I hear a niner in there somewhere? Did I hear a niner? Why is this here? I heard a niner in there. 3 times 3, niner. B to the 7th cubed. Power to a power, 21. 4 times 3, 12. Good to go. That's not the only way to get to that correct answer. You could have made this into a 9th and this into a 12th and then applied them in there, and you're going to get the same answer no matter what. This guy here, maybe we want to make it into m to the 8th and p cubed. So I did 2 to the 4th and got 8. All to the 5th, 8 times 5, 40. P cubed to the 5th, I got 15, and we're good to go. Okay, quotient. If I do 2 to the 7th over 2 to the 4th, I have nothing but multiplication on top and nothing but multiplication on the bottom, which means I can cancel a bunch of things out. This 2 can cancel with this 2, and this 2 can cancel with this 2, and boom, and boom, and boom, and boom. So those 4 on top canceled out those 4 on the bottom, which means I'm left with 2 to the 3rd on the top. Well, what is the association between 7 and 4 and 3? Hey, I think we're going to be doing some subtraction. How fun is that? To divide 2 powers with the same base, subtract the exponents. I don't even like to look at it as much as a subtraction, as there's 3 g's on top and 1 g on the bottom. 1 g will cancel out with, will cancel one of those 3 on the top. Again, you could think of this as there's 7 on top and 4 on the bottom. 4 of them are going away. It is subtraction, but it's almost just as easy to say, you know, this one goes away, which means one of these goes away. So I have a g squared. And yes, 3 minus 1 is 2. Same thing, 5 minus 3 is 2. But these 3 cancel out with 3 of those. There has to be 2 left. So I get h squared. 5 minus 3 would be 4 squared. Bottom one, 7 of k's and 5 k's. Got to be 2 left over. 10 on the top, 3 on the bottom, got to be 7 left over. 1 on top, 1 on the bottom, got to be no p's left over. That's all that we have there. So it's kind of a cancellation, just like when we're simplifying. That's all that we're doing here, is simplifying. Power of a quotient is the same thing as the power of a product. You're going to raise everything that is being divided, quotient, answer to a division problem. Raise the a to the m, raise the b to the m. So if I have a problem like this, I have to do everything to the 4th. If I have a problem like this, I got 3 squared. I got p cubed squared. Raising a power to a power, multiply. So all of these things are going to carry over. So everything in there needs to be raised to the 2nd power. 3 squared, x to the 4th squared, and 4 squared. Obviously, I'm not simplifying these now, but you may be asked to simplify this to 9 over 16, 9x to the 8th over 16, or something like that. Anything to the power of 0 is equal to the number 1. It actually takes the entire variable and it goes away. This is equal to 1. 5x's on top, 3x's on the bottom. Leaves me with 2 x's. This is the number 1. Don't have to worry about it. This f to the 0 is the number 1. I'm left with y to the 5th over f squared. Any non-zero raised to the 0 power is equal to the number 1. So that's, we end up going to a whole number from it. Last thing, negative exponents. Any non-zero number raised to a negative power is a negative exponent. And the biggest thing you have to pay attention to is you're often going to be asked to put your answer with all positive exponents. If I use the subtraction rule here, 3 minus 5 is c to the negative 2. If I use my simplification idea, I have 3 on the top, 5 on the bottom. I will have 2 left over on the bottom. These two things are the same thing. Remember, if we have a negative exponent in the numerator, we can move it to the denominator and it becomes positive. If we have a negative exponent in the denominator, we move it to the numerator. It becomes positive. P to the fourth is still there. This guy, if it's a negative 5, it goes down. It's a positive 5. Boom goes the dynamite. Here it is, all the marbles. A to the negative n is equal to 1 over a to the n. Negative exponent on top goes down, negative exponent on the bottom comes up, and vice versa. So if I was simplifying this guy, a problem is going to say simplify and make sure that all of your exponents are positive. I have a w on top. I have an x squared on the bottom. These 3 v's are going to go to the bottom. Those 3 v's show up down there. And now I can simplify the bottom. And I get wx squared over v to the 6th. Again, the subtraction part of it, negative 3 minus 3 is negative 6. But that would be on the top, and we want it to be positive on the bottom. Recognize this is the number 1. That's the number 1. 4 b's on top, 2 b's on the bottom, b squared here. V cubed is going to stay on the bottom. There's nothing to do there. 2x's on the top, 3 on the bottom. Again, subtraction gives me negative 1, but we need to leave our answers with negative exponents. Don't forget 39 over 13. Hey, we can simplify that. It's 3, and it's on the top. 4b's on the bottom. Negative 3. Those negative 3's are coming up. So I've got a b to the 4th up here. These 3 come up from the bottom floor to hang out there. This u and these 7 u's, they're going to simplify themselves. 6 on the bottom, and then this x to the negative 2 goes down to x squared. Kind of made a mess here, and I'm not quite done. So let's go back to where we started. I got the 3 from the 39 over 3. I'm going to have b to the 7th on top, and I've got u to the 6th and x squared. 3 goes up to join those. U over u to the 7th simplifies itself down to the 6th, and the next to the negative 2 goes down. And division. The difference here is order of operations, 4n squared plus 20n divided by 4n. This means do the division first. I would rewrite this problem like this, 4n squared plus 20n over 4n. And now we could simplify the 20n over 4n, and that would simplify to 5. Notice this 4n squared has nothing to do with that division sign. However, over here, I am putting everything over 4n because it's in parentheses. When I put everything over 4n, I now get 4n squared over 4n plus, that should have been 20. I almost made my first mistake of the year, over 4n. And this ends up being n plus 5. Notice the difference. These parentheses means put everything over the 4n. This means just put the 20n over the 4n. Recognize the difference. This is going to be everything over 2x. Everything over 2x. Everything over 2x simplifies to 2 x squared over x, x on top, minus 9er. Did I hear a 9er in there? And I have an n on top and an x on the bottom. And that's it. That's all we can do. This guy says put everything over 3y. 2y squared over 3y. 3y over 3y. Hey, I know what number that is. Woohoo! 9 over 3y. I get 2y over 3. 2 on top, 1 on the bottom. This is the number 1. Make it look fancy. Sweet. And finally 3 over y. And there we have it. Parentheses. Everything is over 3y. And that's it. So you have a worksheet now that'll go along and tell you what book problems to do that should be handed out, and you can complete your assignment for Chapter 7 Intro. The Chapter 7 Intro. Have a lovely day.